going to pick up where we left off here yesterday on page 170, the review test. We finished up our factors. So now we're going to talk a little bit about multiples, which are kind of the opposite of factors, right? Of the prime number 3. Okay, so tell me, Lawson, what is a prime number?
I don't know, that's why I asked you.
I know. I was wondering if you got your answer yet. Okay, who can help Lawson? What is a prime number? Harper?
Like, prime number, something that, like, I don't know how to put it, but, like, if it's not in your multiple
Wait, stop.
chart, or something, like, it has it, like, these here on number 7, it are the ones that we do not treat as prime, because it says select the factor of your 45 is what, like, a certain number, trying to see what can get in 45, usually those are prime numbers, but the ones that we treat are not prime.
Okay, so let me help you a little bit, Harper. We know that 45 is composite because it has at least 1, 2, 3 factor pairs, right? So a composite number like 45, so maybe if you wanted to write this down so that you remember when you do your test, composite has more than 1 factor pair, right? I'm going to draw it like this, greater than 1, more than 1, nope, just more than 1, not equal to. More than 1 factor pair. So if a composite number has more than 1 factor pair, a prime number has what? Mubina? Only 1 factor pair. Only 1 factor pair. And what is it always? Yes, Brandy?
I think it is a prime.
3 is a prime number because there's only 1 factor pair. And what is the factor pair of 3?
1.
1 and 3, right? So 1's always a factor. So prime number always has 1 as a factor, right? Okay, so 3 is a prime number. Now it's saying, is a multiple of a prime number also 3? So remember, multiples are like counting numbers if you are counting by 3s. So what would some multiples of 3 be?
1 and 3.
Those are factors. Zala, give me a multiple of 3.
3.
3,
6.
6,
9.
9. Okay, we can stop there. Because this is just saying A, one of them. So the question says, is a multiple of the prime number 3, that's these, 3, 6, 9, are they also prime numbers?
Yeah. Wait. No. Yes. No.
I've got mixed reviews. We all agree that 3 is a prime number, right?
Yes.
So technically, yes, 3 is a prime number.
6 isn't.
And 3 is a multiple.
Yeah.
However, 6
Yeah.
is not a prime number, right?
Yeah.
Because we know that we have 1 and 6. And we just said, Joseph, that it's a multiple of 3. So we know that something times 3 is going to equal 6. We know it's 2. Yep. So we can stop here, Zala, because we know now that it's composite. Doesn't matter how many factors it has, even though this is it. So what would you say?
No.
We could say no or yes, but we could explain why, right? So we could say no, and we could say 3 is a multiple of 3, or 3 is a prime. Lucas. 3 is a prime multiple of 3. But would you agree that all the other multiples are going to be composite?
Well, no. Because 9 isn't composite.
9 is composite because 3 is a factor.
Oh, yeah.
Every other number on this list is going to be divisible by 3. Including 3. 3 is also divisible by 3, but it's just 3 and 1.
Now I
You see?
Yeah. Because 9 is like 3 times 3. And then 12 is 4 times 3.
3 is going to be a factor of every single number, which it is even of 3. The catch is it's just 3 times 1. Okay, so now you're going to explain that, Zala. I feel like you need to put that away.
Okay.
It's distracting you. What are you going to write, Arabella? So I'm going to say but, or however, if I was being fancy. All the other multiples are what?
Composite.
Yeah. Yes, Brandy?
Well, I said my reason is just because three can be put into one, but the multiples are not prime.
Okay. I don't understand when you said 3 can be put into 1.
Like three and 1 are the only ones that can.
Are the only factors?
Yeah.
Okay. Liam? What did you write, Liam? Okay. Yes, Lawson?
I wrote a little bit different, but pretty much the same thing. I wrote no because 3 is a prime number, but 6 is not because you could multiply 2 times 3.
Okay, yes. Yeah. Which is another factor pair, right? Okay, yes. Use this?
I kind of just wait. Listen, can you? So when you said, but 6 is not because you can multiply by 2, kind of sounds like only 6 is a composite number. Like,
Although it does say is a multiple, so 6 is a multiple. It's not asking about technically, if it's not asking about all the multiples.
right? Yeah.
So either way is right. You're both right. All right, shall we move on? Sammy did. Sammy is over it. Sammy, when you go forward, you just have to make sure that you come back and listen. And I want to see the correct answers on your booklet, okay? Okay, number 9. For these numbers, choose yes or no to tell whether or not the number is prime. Okay, so we got to pull this out, right? Now we don't have to list all the factors. Here's the shortcut. You just have to figure out if there's a factor other than 1. So what are your thoughts on 49?
No.
No.
No, I don't know.
7 times 7.
7 times 7, we know, so 7 is a factor, so this is not prime. What about 53?
No. Oh, 63.
Yeah, yes.
63.
53.
Oh, 53.
No, I mean, yes.
Yes.
Because if you're looking at your multiplication chart,
No.
53.
right, and if you don't have a multiplication chart on your desk, like some of you are getting tired of them, if you actually need to refer to them and you don't have your name tag on your desk, did you all know that you have a multiplication chart in your planner?
Yeah.
Yep. So you can refer to that, like Sammy, if you wanted a multiplication chart for some reason, you can pull out your planner and take a look. But it's good for us to be kind of taking these off because we should be learning our math facts. We shouldn't have to look at our multiplication chart forever. Okay, so that's okay. So if I go through the tricks really fast, I can just do them. I know 1's going to be a factor. 2 is not going to be a factor. 3, I can check. Let's see, 5 plus 3 is 8. Not. 4, nope, because it's not even. 5, nope, because it's not 0 and 5. 6, nope, because 2 and 3 aren't factors. 7, I get close, but not 53. 8, I don't get it. I get 56. 9 doesn't work, and 10 doesn't work. So 53 is going to be prime.
The same as 63.
Oh, no, no, no.
63, yeah.
Because I can add,
Yeah, you can do 7 times 9 equals 63.
and I can add 6 plus 3 equals 9, which means it's also divisible by 3. It's also divisible by 7, so this one's not prime because we've got a lot of factors, right?
Yeah.
Now we've got 37, so that one's not so familiar. We can check it. 1, we know. 2, no. 3, I know 7 plus 3 is going to be 8, 9, 10, not divisible by 3. It's not even, not a 0 or a 5. 6, it's not divisible by 2 or 3. 7, not a multiple of 7. 8, not a multiple of 8. 9 and 10, nope. 37 is
Yes.
prime. 51. Well, one might think it's prime if they didn't use their factoring checklist to check. Because as soon as you get to the 3's, you would add 5 plus 1 and get 6, and you would discover, oh, 6 is divisible by 3, therefore 51 is divisible by 3. Don't be fooled. Some 4th graders look at this and go, it's an odd number, it must be prime. But it is not prime, because I can do 51 divided by 3 and get 17.
Wait, so it's no, yes, no, yes.
So 3 and 17 are factors, therefore this one is not prime. That's how they trick you. That's why I gave you these charts, because that's really important. Okay, now here's another confusing box. Classify each number from the list as being a multiple of 2, 3, or 5. Write each number in the correct box. This one's important. If you have a highlighter, you might want to highlight this. A number can be written in more than one box.
Oh.
So you can't write the number down and then cross it off. Okay? So 18, is it a multiple of 2? Which I can think in my mind,
Yeah.
I can think, even though we're talking about multiples and multiply, I can think, can I divide evenly by?
That just makes me more confused.
So watch how it works. 18, can I divide it evenly by 2?
Yes.
Yes, because 18 divided by 2 is going to be 9 with no remainder. So 18 is going to go here. Can I divide it evenly by 3?
Yes, yeah.
Because 3 times 6 is 18. Can I divide it evenly by 5?
No.
No. Or I could think 2 times something give me 19, 18, 3 times something give me 18, 5 times something give me 18. Do you see? Okay. I'm going to give you a moment to think about 30, 20, 24, 55, and 39, and then we'll check.
30 times 2 is 50.
You, Sammy, did you notice that it said a number can go into more than one box?
Doesn't go in any of the boxes.
39, you mean?
Doesn't go in any of the boxes.
Yes, it does.
Okay, did y'all notice that 30 goes in every box?
Yes.
Yeah.
Yep.
So does 20.
No, 20.
No, 20 does not. It's only 30.
No, it doesn't.
Okay, 20 doesn't go in every box because it's not a multiple of 3, right? So 20 goes here and here.
Yep.
Never
I thought my
mind,
30
I
was
made
a 20.
And then
24 goes in 2 and 3, right?
Yeah.
Yeah.
And then
Not a multiple of 5. 55 only goes in one box.
5.
Yep, 55 goes in 5. And Brandy says 39
Goes into 3.
goes into 3. She found one box because I can tell 3 plus 9 is going to be 9, 10, 11, 12. 12 is divisible by 3. So 39 goes here.
I did not get
Any questions about that?
What is this? No. Oh, wait, why didn't I put 30 in there? Wait, yeah. Yep, I got it.
Okay. Use the rule. So remember rule. Aha, they give it to you multiply by 2. I'm going to give you a minute to see. We just did this the other day. Just remember when you go from one box to the next, you're going to multiply by
2.
2. See what you get, Lucas.
Done.
You could start working on this one, draw the next term of the pattern.
Oh, I have a message for me. I just did the equations for this.
Oh, by the way, everyone, I was texting with Mrs. TK last night. So those of you missing Mrs. TK, she has COVID. She misses everyone terribly. She wanted me to tell y'all that she missed you. All week, she said all week. Okay, so did you get 64? And 128? Ooh, I even heard a yes from Arabella. And a 256? Yes. Okay. Draw the next term of the pattern. So we're looking for how it's increasing. So I'm noticing that I'm getting one more here on the bottom, right?
And then 2 more.
And then 2 more on the top. So I'm gonna repeat this pattern. That's my strategy is kind of do the basic. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. Okay. I'm just redrawing this pattern that's here first. So now I've got a duplicate. So I can add my extra here, Lucas. So now instead of 4 on the bottom, I have 5. And then instead of 7 on the side here, I would have 9. So I've added this one, these, and this.
I spread the boxes apart. So
That's no problem.
it may look like
As long as it counts up. So the point is I just want you to come up with your own method. That's my method, is to first find out what's increasing, then copy the last term, and then do the increase. That makes sense, Liam? Yes, Yusuf?
What I did, I just first of all, obviously I saw what was increasing, I guess.
Yep.
And then I just redrew the drawing or the term or whatever.
Yep.
On the one before, just so it could give me an idea, and I just copied it off.
Perfect. Is that different than what I did?
Well, no, because I drew 2 extra squares on the one before.
Ah, you drew on this one to see, and then I copied it. Ah, I see. Alrighty. Are we ready to turn the page? To number 13. Yep, go for it, Brandy.
a team of workers is building a 942-foot trail. Wow. They plan to complete 6 feet per hour. How many hours will it take to build the trail? Choose the equation that can be used to solve this problem. Mark all that afterwards.
Apply. Mark all that apply. So do you notice that this problem doesn't say solve?
Yeah.
Did anyone notice that?
I can solve it. It's really easy.
So here's what I'm going to give you. I'm going to give you a bonus point
Oh, let's go. To solve.
to solve for H. Okay,
Right now, but it says
here and on your test.
in the test. I get 2 points.
So especially for me, like when we were remember when we were doing that quiz and I solved the problem first and then chose the big long equation, that might help too. This is also a big clue, you guys, with your highlighters out. Lawson and Mohammed, you might want to highlight this. This is a special test. Sammy, you're missing this note. This is a special test secret code for more than one answer.
I know.
Okay, so what do you guys think? Barrett?
I was on the other side of the desk.
Okay.
Can I get it?
Yeah. Who has an answer for this one? What do you think for an equation? Cody, what's a good equation to solve this problem?
942 divided by 6 equals 8 and 942 divided by 6 equals 6. I mean, 942 divided by 8.
Okay, so these two? Is that what you're saying?
Yeah,
Because I'm thinking 942 is going to be in the middle, right? And I'm going to have 6 and h on the outside, which means I can switch these factors around, right?
Mm-hmm.
So there's another equation that works.
Wait, what?
Liam?
Oh, yeah.
What? D, as in dog? Yep, that's correct. And when you draw it like this, do you agree that you can see it easily?
Yeah.
Because now I know, oh yeah, 6 times h, just like our drops when we did the area of the rugs in the pool, is going to give us 942. Yes, Lawson?
Well, I didn't write down the 6 times digit was 942, but now that I write down, I don't know why I didn't see that because it's kind of that's pretty much.
Probably because you guys are thinking divide, right?
Yeah.
You're going to divide to solve the problem. You found 2, which is more than 1, so you're good. Sammy, did you get all 3 of these? Show me. You did, smart cookie. Okay, what's the answer? What does h equal?
156. Remainder 6. So 157.
Yep, I got 157. H equals 157. All right, go ahead and do number 14. And then you can start number 15. Can I have a reader for number 14? Julian, go for it.
Roger first ships a large number of packages. Then he ships 3,821 packages. Roger ships 22,540 packages in all. How many packages did he ship first? Identify the technical terms and addition or multiplication, then write and solve an equation to solve the problem.
Okay, so I'm going to have to do a comparison bar, right? That's the magic word. Comparison. Okay, so I'm going to give you some time to think about this on your own while I think about it too.
Oh, I know what to do.
Lucas, are you thinking about this problem?
I know I am right now.
Great. Ooh, I could also see it this way. All right. How are you going to solve this problem? How are you going to solve this problem? Mohammed, what would you do to solve this problem? Olivia, what would you do to solve this problem?
I would do subtraction, but it says to just pick addition.
It says comparison additions.
So I did 3,820 plus and equals 2,027,540.
Beautiful. Okay, so I heard her say I did 3,820 plus n because it told me I needed to do some addition, but I don't know what I'm adding because that's the missing information, right? But I do know what we have at the end. But so in the type of comparison you had to pick was addition or multiplication.
I did addition.
Now, did you add, however, to solve this problem?
No.
No. What did you do instead?
Subtract.
Subtract. Tricky, right? Did you get 18,720 packages?
I'm not finished yet.
Yes, Yusuf?
I kind of like added and subtracted,
Cool.
so
Did you get 18,720?
Yeah.
Awesome. Are you still working on it, Joseph? So now just go through it with us, Yummy, and check your work.
18,720.
Okay. Ooh, when I see parentheses, what am I gonna think? Parentheses, exponents, multiply or divide, add, subtract, easy as that. Use PEMDAS to get it right.
I keep calling them pandemic.
Not pandemic. That's a word we all know now.
I said pandemic.
So once we see what's in the parentheses, 6 plus 2 is 8. It makes this problem really easy, right? 72 divided by 8, is it 9?
Yes.
9 times 8, 72, yes.
True.
7 plus 2 is 9. 6 take away 2 is 4. 9 plus 4 is 36. Is it true? No. 9 times 4. I try to trick you. Okay, 12 plus 8, let's see, 8, 9, 10 is 20. 20 divided by 4. Uh-oh, now I've got another expression. Let's see.
Oh.
So 5 take away 3 is
It's true.
2. So is 20 divided by 4 is 5. 10 divided by 2 is 5. Is this equation equal?
Yes.
Yep. Any questions on that so far? 35 take away 8. What'd you get, Lily?
27.
Anybody else get 27? Yep. And 2 plus 1 is 3. 27 divided by 3 is not 32.
if it was addition, kind of.
Puzzle Penguin must have solved these problems, huh?
Yeah.
Any questions on this one?
Because in the first and third.
Sammy, how'd you do? Get them all right? Okay. I'm glad you're fixing it. Doing okay, Zala? All right. We'll do a couple more, then we'll take a little break. Oh, let's do this one more problem. Did you notice that this page is one problem? We're going to finish this page, and then we'll take a little movement break. Yep, number 16. Part A, Part B, Part C. Yes, Mohammed? Sorry, I can't hear you. Nope, there's one more. Charlotte made this pictograph to show the number of dogs attending the dog training class this week. Guys, circle this part. This part gets all 4th graders. The little puppy paw equals not 1 dog, but 3. Okay. How many fewer dogs were in the training class on Monday than Friday? So I'm going to do Friday and Monday. Fewer on Monday. So draw your unit boxes to help you, Zala. Harper, how many dogs were there on Friday? How many dogs were there on Friday? So each paw equals 3. So count the paws for Friday. 7. So 7 times 3 is 21. And how many then were there on Monday?
9.
Because there's 3 paws, so 3 times 3 is 9. And it says how many fewer, so we want to find the difference.
So 21 minus 9.
21 minus 9 would be your equation, equals a variable. Remember, Lawson's going to remember that because he wrote it on the first page, right?
Yep.
Use variables. And Mason, what answer did you get? F equals what? 12. Okay. Part B, choose a number that makes sense or makes the sentence true. Charlotte forgot to include Thursday on her graph. Oh no. There were 2 times as many dogs at Thursday's class than on Monday.
Oh, that's 18 dogs.
So how many were there on Monday?
18. Oh, 9.
9. There were 2 times as many at Thursday's class. So 9 times 2 is 18. So the answer would be 18. And then how would you explain how you determined the number of dogs on Thursday's class? Arabella, tell us what you did.
So, what I wrote down.
Yeah, or what you would write down for part C.
I was like,
Listen and write something down, okay?
I did 9 times 2. I did 9 times 2.
Okay,
And then I got 18.
great. And you want to could someone add on to that and explain a little bit more about like how you got 9?
Oh, can I?
Brandy?
I said I got 18 because 9 times 2 is 18 and there was 9 dogs on Monday.
9 dogs on Monday. Want to add a little bit more to that, Yusuf? You're
Yeah,
listening and
I
thinking
will-
about something to write down.
Oh, it says 2 times as many on Monday, and on Monday there's 9 that looks like an 8. There's 9, so I multiplied and got 18. Multiplied by 2.
Yep, multiply by 2. Barrett?
I said
Thank you,
Monday
Yusuf.
was 9, then times 2 equals D. D equals 18.
Great. Did anyone mention something about there are 3 paw prints on the pictograph?
Oh.
And each paw print stands for 3 dogs. Did you, Lee? Did you, Liam? What did you write, Liam?
I did, so part C.
Yep.
I wrote there were 3 paws and each paw is 3 dogs, so there were 2 times as many on Monday, so 9 times 2 is 18.
Beautiful. Okay. All of those explanations would be phenomenal for this part C. Okay. Number 17. Mohammed. Samuel, will you read this one?
I'm just gonna say
The Ruiz.
Ruiz family got 2
Mohammed.
adult tickets.
Sorry, Sammy.
The Ruiz family bought 2 adult tickets and 4 child tickets to the fair. The adult tickets cost $8 each. The child tickets cost $3.
Well, this reminds me of a quiz question. Okay. Keep going, Sammy.
Complete the equation Zach and Alana wrote to find the total cost of the tickets bought by the Ruiz family.
Okay, so what do you guys think here?
8 times 2. And then 4 times 3.
Okay, so adult. They've got 2 adult tickets. And each adult tickets cost $8. Brandy's waving and talking. Brandy?
I was confused for just a second because I put 4 times 2 on half.
Oh, be careful. Now we've got 4 child tickets. And each child's ticket costs $3. Yes, Arabella? Oop, just dancing. Okay. Okay, so Zach's answer is $72 and Alana's answer is $28. Uh-oh.
Oh, whoa.
Who has the wrong answer? So we better figure out what is the right answer. So I'm going to give you a moment to solve for C. Ready, go. Okay, Naya got 28. Did anybody else get 28?
Yeah.
Yep, I also get 28. So, who has the wrong answer? Harper, what would you write? Sorry, guys. Harper, what would you write? Who has the wrong answer? Do you need time, Harper, or help? Time. Okay, we'll give her some time so you don't have to dance around. No.
We're allowed to move on.
Okay. So look up here, Harper. We put in 2 and 8 because 2 adult tickets and each one cost $8. So that's what this problem is tricky. We have to read it a little carefully. And I can't. And they try to give you a little clue by putting the 4 in here because they're saying, okay, 4 times what? So 4 is the number of children. And the children's tickets cost $3 each, right? So we're going to do 4 times 3. This is the kids. And then this is for the adults. There's 2 adults, and each ticket costs $8. Does that make sense? So then, because we know PEMDAS, we're going to do what's in the parentheses first. 2 times 8 is 16. 4 times 3 is 12. And then we still have this plus. Yep. So add them up. And then you get 28, right? Like Alana. So who got the answer wrong? Zach.
Sorry, Zach.
So Zach's answer is wrong. So now we have to think about, it says explain what error he made. So now you have to be the teacher and figure out what in the heck did Zach do to get this big number 72. Naya, what do you think?
I think he times 16 times 12.
I tried that.
Does it work? 16 times 12?
No.
No?
It was I did
Well, I'm thinking this is way more than 10, and this is close to 10. So 10 times 10 is going to be 100, so that'd be even more, right?
Oh, I know what he did.
Sammy, what do you think he did?
Well, this isn't about the answer, but thinking of like 10 dots over 2, like on top of your question, the equation. I was confused at first because I didn't know, like, they're both multiply and in parentheses, so I didn't know which one to do first, and then I realized you go left to right.
Okay, yeah. Lily?
I think he did 4 plus 3 plus 2 times 8.
4 plus 3 plus 2 times 8. 4 plus 3. Okay. What if he just ignored the parentheses altogether? What if he forgot PEMDAS?
What if he doesn't know?
So let's try it. 2 times 8. What is it?
16.
16 plus 4
20.
is 20. Nope, that doesn't do it either, huh? Times 3, that would be
90.
4 plus 3 Not
Six,
plus
nine.
2
That's
plus
six?
times 9.
Sorry, Lily, say that again.
4 plus 3 plus 2 times 8.
4 plus 3 plus 2 times 8.
Yeah.
Like he just mixed them all up, huh?
Yeah.
Yep. So he did something with the numbers, but it didn't make sense. He didn't do it in the right order, right? So clearly he forgot all about PEMDAS.
He forgot
He forgot all about PEMDAS, or maybe you wrote something, Lucas, about he didn't do what's in the parentheses first.
Yes, I just said
I said exactly.
because he did 9 times 8, which goes up to 72.
But there's no 9, so he probably didn't do that. 9 times 8 does equal 72.
probably just like
I said Zach has the right answer because 16 plus 12 is
That doesn't make any sense. 16 plus 12.
No, I'm saying
28.
I said Doc
Oh.
answer because 16 plus 12 is 8.
No, 16 plus 12 is 28.
I meant 28.
This is just asking what was the error he made.
28.
All right, if you can hear me, say shh. Okay, put your bottom in your chair for the last problem of the review test. Zala, will you read number 18, please?
Okay, a store has 4 bins of planet posters with 23 posters in each bin. They had 3 bins of planet calendars with 26 calendars in each bin. Yesterday, 72 calendars were sold. How many planet posters and calendars are left? Explain how you found your answer and how you know if your answer is reasonable.
Ugh, okay. This is a lot. Confusing. So as Zala was talking, I started thinking, uh-oh, I've got posters and calendars. Brandy, I'm going to make some uniboxes.
Okay.
Okay. So when it starts with the posters, we got 4 times 23, right? 4 bins with 23 each. Then we had 3 bins of 26 each calendars. So this is how much they started with. Do you agree?
yes.
Then they sold some calendars, so that's adding on. So I think that before we even deal with this part, 72 calendars were sold. I feel like we should figure out how many they started with. What do you think? Okay, so let's solve for 4 times 23 and 3 times 26. Go ahead and get started, Joseph. So there's 4 bins with 23 posters in each bin. So if you wanted to solve for posters, how many posters there are, you would do 4 bins times 23 posters.
And then you add up, and then you subtract, and then you
4 times. Then, guys, can you please be quiet? Then if I wanted to figure out how many calendars there were to start before they sold any, it says they had 3 bins each with 26 calendars in them. So I would do 3 times 26. You with me so far? Great. So now I'm giving you a moment to do 4 times 23 and 3 times 26. Go.
Do we have to add?
I'm asking you to solve 4 times 23 first to figure out how many posters. Did you do it already?
Yeah, I did it all already.
What'd you get, Brandy?
What did I get?
Yep.
For which one?
How about 4 times 23? How many posters did they start with?
Oh, that's 23. I said 28.
Whoops. Mubina, what'd you get? 4 times 23.
For the TV, I got 92.
Me too.
Agree. Yeah, 92.
And Ava, how many calendars did you get?
I got 78.
78. Me too.
Agree.
At first I got 88.
Okay, now it says they sold 72 calendars and it wants us to tell how many are left in all. So what are we gonna do now? What would you do, Julian?
Subtract.
Tell me more.
I will subtract 78 minus 72 because they sold 72.
Okay, yeah, we could do that way. 78 minus 72, and then what do we get?
6.
So now there's only 6 calendars.
These calendars are so now they need to be stopped.
So then it says how many planet posters and calendars are left. What would you do, Arabella? So we figured out that there were 92 posters. And they started with 78 calendars, but they sold 72 of them, so now they only have 6 left. So we have 92 posters and 6 calendars, and it says how many are left in all. What would we do? Add them up. 92 plus 6 gives you what?
98.
98 calendars and posters. Okay.
I thought it asked just how many calendars there are left.
I'm gonna say
Let's go back and check the question to make sure that we've answered it completely. How many planet posters and calendars are left in all? We got it. Explain how you found your answer and how you know your answer is reasonable. What are you writing, Joseph?
Yeah.
What are you writing? Can you tell us?
I'm gonna write how my answer was reasonable because how many planet posters and calendars were left in all, because all is each word, and so then that would have to be 98.
Okay. Anyone else want to give it a try? Thank you, Joseph. What do you think, Zala?
I think that my answer was reasonable because, for example, like 4 bins with 23 posters in it, there needs to be more than 23 posters.
Oh.
And
You know you're going to end up with more than 23 because they didn't sell any of those? Brilliant. That's a good idea. So Joseph had a good explanation. Zala has a good explanation. Barrett, what'd you have?
I said 98 in all,
Okay.
but how I got it was 26 times 3 equals 78 plus 23 times 4 equals 92.
Yep.
And then 90, and then 78, take away 6 is 72.
Yep.
And then I added that.
Brilliant. Okay.
Wait, is that what it is?
Yeah. We added them in the end. So I'm going to give you a bonus point on this problem for one equation. Can you write one equation that shows how we solve the problem?
I wrote a bunch of equations.
One equation. Yes, so I want you to explain it just like Barrett did. I want you to tell why it's reasonable just like Zala and Joseph did. And that's complete. That's 3 points. You're going to give me the answer, you're going to give me an explanation, and then tell how it's reasonable. That's 3 points, but I'll give you a bonus point.
What?
4 points if you can put it one equation to show everything that we did. So I'm going to guess you didn't do that. So why don't you take a moment to do it now? Sammy, one big equation. Zala, one big equation. Liam, what was your equation?
I did 4 times 23 equals 92, and then 26 times 3 equals 78, and then 72 minus 78 equals 6, and 92 plus 6. Oh my god. 98.
But that's 4 equal signs, and an equation has only one. Yeah. This is a double bonus. No, it's not. It's just evil.
How about just 2 points because it's
since it's so hard to put together.
Sure.
Yeah, 2 points.
Yes.
I'll give you 2 bonus points. If you can come up with one equation that shows the whole process.
You are brutal.
Lawson.
I don't think this is right, but I wrote 4 times 23 in parentheses,
Okay.
plus 26 times 3 in parentheses, minus 72 equals 98.
That could work. That could work. Sammy?
So vertically, I think it's called. I did 92 plus 78, and then I did the answer. I left the answer thing, and then I did minus 72 equals 1.
But so every time you put a line like this, it's an equal sign.
Yeah.
So you can only have one equal sign.
Wait, when you say equation, do you mean like the parentheses equation thing?
Uh-huh. Sometimes equations have parentheses.
Alright, because I made mine in parentheses 4 times 23 plus also in parentheses 3 times 26 minus 72 plus 6 equals v.
So I think so. So I would do it something like this. Do you guys all agree that first we multiply
Yeah.
these 2 numbers
And then add it.
and then we added them together, right?
Subtract.
And this isn't exactly how we did it because first we subtracted, but it would have been equally correct if we added them together and then subtracted, wouldn't it? We could have done 78 plus 92 and then subtracted 72. And then we would have gotten 6. And then what did we have to do with the 6? We had to,
Subtracted.
then we had to
Add it. To
added the 6.
Yeah, and
Huh.
I said 72 plus 6. Wait.
Yeah. So I think we'd almost have to add this,
Yeah, that's exactly.
which is kind of what we had to figure out. Yeah.
Yep, that's my problem.
It's confusing.
I got
Yes,
so
Zala.
confused with the words you said.
Let's say you wanted